Do you ever find yourself being drawn to the fridge more when it's packed with food, and find it harder to stay away from it when it's full? Well, physics is the answer to this, and this answer is gravity. In simple terms, it is because the greater the mass of the fridge, i.e. the more food it has in it, the greater its gravitational pull, and therefore the greater the attractive force exerted on you. But before we tackle the subject of gravity and how it works, it's important that we understand the difference between weight and mass. The mass of a person is a measure of how much mass it contains and therefore how much inertia it displays. Don't be confused with this word inertia, it's a simple concept really. Any object with a mass has a quality called inertia. Inertia is the resistance of any physical object to any change in state of motion. For example, if you roll a bouncy ball along the floor, it takes a force from you to start it moving, and it will also take another force from you to stop this movement. So, if the ball is at rest, it will want to remain at rest, but once it's moving, it wants to stay moving. Weight is a completely different thing altogether. The first thing to understand is that every object that has a mass will attract every other object with a mass. The extent of this attraction depends on how far apart the masses are and the size of the masses. You won't notice this effect for everyday size objects because the gravitational pull is negligible. However, for gigantic objects, such as the Earth, this force is so strong that it can prevent us from falling into space. And this force can easily be measured. All you have to do is stand on a scale. You see, scales measure the force of attraction between you and the Earth, and this attraction is called your weight. However, if you are floating in a spaceship light years away from a planet or star, and you put a scale underneath you, you would have no weight. Nor would your biscuit floating next to you, both weightless. But would you both be massless? Absolutely not. If you grabbed your biscuit and tried to shake it, you would have to push it to get it going and push it to stop again. It still has inertia, and hence mass, yet no weight. This force of gravity depends on two things. Number one, it depends on your mass and the mass of the planet you're standing on. If you double your mass, gravity pulls on you twice as hard. Equally, if the planet you're standing on is twice as big, gravity will pull you twice as hard. And number two, the greater the distance between you and the centre of the planet, the weaker the pull between the planet and your body. If you double your distance from the planet, the force is 1/4. If you triple this distance, the force drops to 1/9. And if the distance is 10 times bigger, then the force is 1/100. This relationship has helpfully been formed into a scary looking equation by Sir Isaac Newton. The F stands for the force. The two M's on top are your mass and the planet's mass. And the R underneath is the distance from the centre of the planet. Now you may assume that because Jupiter is 318 times bigger than Earth, that you would weigh 318 times what you weigh at home. And this would be correct if Jupiter was the same size as Earth, but Jupiter is 11 times the radius of Earth, so you're 11 times further from the centre. This reduces the pull by a factor of 11 squared. So someone who weighs 150 pounds on Earth would, if it were possible to stand on Jupiter, weigh 354 pounds. And on the other end of the spectrum, if you were to stand on Pluto, a 150-pound person would weigh only 10 pounds. Gravity is such a mystical thing that it even has its very own day dedicated solely to it. Gravity Day is on the 8th of September, which represents a constant of the gravitational pull on Earth, which is equal to 9.8 newtons per kilogram. But before we get too carried away praising the strength and wonder of gravity, just remember that a fingernail-sized magnet has enough electromagnetic force to overcome all of the Earth's gravity and stick to the fridge. Thanks for watching!